So now we're going to look at falling and falling. So the value of cell phones changes exponentially after your initial release. So a cell phone starts off expensive and then eventually it just depreciates in value the years after the release because the new ones come out and then no one wants to buy the old ones. So as we look here with an exponential equation, just a reminder, the form is y equals a times b to the x. A is your initial value, and B is your growth factor, which in this case it's going to be decay because the values are going down. So over here, if I look at phone A, my initial value is A is 1,000. So this phone started off at the $1,000. Who knows? This could be your iPhone 12 or like, what if they just do iPhone, 13 XS Max 5 with the biggest screen ever or a small screen, phone features are always new and changing. So to find the growth or decay factor, we can go between consecutive years. So here, we can take the y2 value and divide it by the y1 value, which is 600 divided by 1,000. And in this case, I really can just simplify. So I could divide by 10 and cancel out the zeros. And b is going to equal 6 over 10 as a fraction. Or you could write this as a decimal as 0.6. So my equation for this phone would be y equals 1,000 times 0.6 to the x. And if we look over here, this phone, the initial value is 840. And my growth factor here would be 630 divided by 840. And that is 75. So my equation would be y equals 840 times 0.75 to the x. So in looking at this, which phone is more expensive when it's first released? Phone A is $1,000. Which that's quite an expensive phone. Parents are like, yeah, that's a no for me, unless you get your own job and pay for it yourself. So down here, how does the value of the phone change with every year? So if you look, phone A, and if our growth factor is 0.6, it keeps 60% of its value. Which as a decimal, 0.6 is 0.60, which would, if you move the decimal 2 spots, become 60%. And then looking at here, phone B keeps 75% of its value because 0.75 as a percent is 75%. So which phone is falling, or which one is falling in value more quickly? If you're only keeping 60% of its value compared to keeping 75% of its value, it's phone A. We can look at the graph. The graph has a more steep decline, whereas the graph here does not. So you could see here in the graph, the slope is more negative whereas this slope is not as steep. So phone A, and we could say the graph is steeper. And the growth factor is a smaller decimal, or the decay factor is a smaller decimal. So if the phones continue to depreciate by the same factor each year, what will the value of each phone be 4 years after it's released? So for phone A, we can plug that in. 1,000 times 0.6. You can put the 0 in if you want. To the fourth power. And phone A is going to be worth $129, and that would be 60 cents. And I'm going to put the dollar sign. And then here, if we're making an equation where they say V, the value of phone A, and T years, we can just put phone A's value is equal to, and then just put T in to our expression there. So 1,000 times 0.6 to the T. Now we're going to work with phone B. So after 4 years, we're just going to plug in 4. So we type in 840, its initial value, times 0.75, the decay factor, to the fourth power, and we get 265.78. And then as we put that in, the equation for phone B is V equals 840 times 0.6 to the T.